All right, this is a continuation of Module 6, Lesson 4. I'm on page 282. All right, I'm looking at C. We have manipulated the slope, and we have noticed that as the slope gets closer to 0, the line gets less steep or flatter. As the slope increases, the line gets steeper or more vertical. Okay? But now we're going to do something a little different. It says, again, press the y equals and clear out all but the parent function. Okay, so I'm going to go to y equals, leave the parent function. So y equals x. We're going to leave that one, but we're going to clear this one and clear this one. Okay. It says, then graph the function f of x is equal to negative x. All right, so that's going to be our y2 line. And make sure the calculator needs you to use this for your negative sign. Okay? So if you want a negative x, you hit the negative and then the x. Okay? And then graph to see your lines. There's the first one, there's the second one. Okay, remember that our parent function, f of x is equal to x, the slope was 1, because that is the unwritten coefficient in front of the x, and the y-intercept was 0. Then we put in f of x is equal to negative x, and it's asking what are the slope and the y-intercept of f of x is equal to negative x. Well, the slope is negative 1, and the y-intercept is still 0. So how are the graphs f of x is equal to x and f of x is equal to negative x, how are they geometrically related? Okay, if you look again at the two lines, this one is the original f of x is equal to x. If you flipped the original line and you flipped it across the y-axis, then you would get f of x is equal to negative x. Okay? So it's kind of a reflection across the y-axis. Okay, let me point out one more thing. So not only are they, in this case, reflections across the y-axis, so I could flip it and I would get this new line, but I would also be able to flip it across the x-axis. So f of x is equal to negative x is a reflection of f of x equals x. Okay? Okay, so you might want to take a minute and write your explanation. In this particular case, I'm not saying it would be true in every case, but in this particular case, this line could be a reflection either across the x-axis or the y-axis. So just write both of that down, and then we're going to do D. It says, again, press y equal and clear out all of the functions. Okay? So take this. So I'm going to go to y equals, clear that, and clear this also. Okay. And then it says to graph f of x is equal to negative x. So that's going to be our first function in the list this time. F of x, remember to hit your negative button, not the minus sign. F of x is equal to negative x. And it says then graph other functions of the form f of x is equal to mx, where m is less than 0, meaning m is a negative number, by entering their rules next to y2, y3, and so on. Okay? Be sure to choose values of m that are less than negative 1, as well as values of m between negative 1 and 0. Okay, first I'm going to do values of m that are less than 1, like negative 2, negative 3, etc. All right, so I'll do that first. Negative 2x. Negative 4x. Okay, when I hit the graph button, it'll do this line, then this line, then this line. So graph, boom, boom, notice that the lines get steeper, more vertical. Now they all have negative slopes, okay, but they are getting steeper as, I guess you could say, as the absolute value of m increases, okay? Okay, so I said when m was less than -1, the slope gets steeper, meaning the slope gets closer to vertical. It's still a negative slope, but it's closer to vertical when m, let's say, is, -3 rather than -1. Okay. Now let's do what the lines are going to look like if m is between -1 and 0. So values that would be between -1 and 0 would be like -0.5, -0.2, etc. Okay, so let's do that. Go back to y equals. We're going to keep the negative x as our parent function. This one we'll do -0.5x. This one will do -0.2x. And again, remember, it will graph in the order. Here we go. Boom, boom, boom. All right, so as the m value, think of it as the absolute value of m, as it gets closer and closer to 0, gets smaller, then the slope of the line gets flatter and flatter. Now, the slope of these lines is still negative, okay, but they're getting more and more horizontal. Okay, so that's basically what I wrote here. When m is greater than -1, but less than 0, so basically when the value of m is between -1 and 0, then the slope is going to get flatter because the slope is a decimal value, okay? And it's going to get closer and closer to horizontal the closer it is to 0. Okay, on number 3 on page 283, this is basically kind of a continuation of the discussion that we're already having with taking the slope and making the line steeper or flatter. If m is greater than 1, will the graph of f of x is equal to mx be a vertical stretch or a vertical shrink? Well, first of all, you might want to write this stuff down. A vertical stretch makes the slope steeper, and we'll call it a vertical shrink if it makes the slope less steep or it makes it flatter, closer to horizontal. Okay? When m is greater than 1, and frankly, when m is less than -1, okay, so this one would be a positive slope, these values would be negative slopes, those are both going to give you a vertical stretch, meaning that those lines are going to get steeper. Okay. When m is less than 1 but greater than 0, or when m is less than 0 but greater than -1, meaning that m is a decimal, that's going to be a vertical shrink. Okay, those lines will be flatter. Okay. And by those lines will be steeper, those lines will be flatter, I mean versus the original line. Okay, f of x is equal to x, or f of x is equal to -x. All right, down here where it says understanding function families, investigate what happens to the graph of f of x equals mx when you change the value of m. Okay, A says a family of functions is a set of functions whose graphs have basic characteristics in common. What do all of these variations that we've been doing on the original function have in common? Well, they are all linear functions. And they would all fit the equation y equals mx plus b. Remember, f of x is the y. A lot of times we've had b is equal to 0, but it doesn't have to be. Okay, so all of these fit that linear function format. Okay, it just so happened I wrote it in slope-intercept form, but it doesn't have to be. All right, the most basic function of a family of functions is called the parent function. What is the parent function of the family of functions explored in the first two activities? Y equals x, or we kept referring to it as f of x equals x. Okay. A parameter is one of the things in a function, one of the constants, that determines which variation of the parent function one is considering. For functions of the form f of x is equal to mx plus b, or y equals mx plus b, what are the two parameters? Basically, they're asking what are the two things that we can manipulate to change from the parent function to something different. Well, we could change the y-intercept value, or we could change the slope. Okay, I'm now on page 284 at the discussion question. For the family of all linear functions, the parent function is f of x is equal to x, where the parameters are m equals 1 and b equals 0. Other examples of families of linear functions are shown below. They all follow the same basic y equals mx plus b format, though. Okay, so if I look at this graph, there are three lines. Y is equal to 2x is this line in the middle. Y is equal to 2x minus 1. Y is equal to 2x plus 2. Okay, for this one, slope is the parameter that remains the same. Okay, and the b, or the y-intercept, changes. On this graph, y equals negative x plus 1, y equals x plus 1, y equals 2x plus 1. On this particular graph, the y-intercept, or the b value, remains unchanged. So they all have the same y-intercept. But the slope is different. Okay. And then we're going to go into taking this information and using it in some actual situations to solve problems.